Hello and welcome to the Earth Observed podcast, a podcast where I sit down with the founders, the technical leaders, and the minds shaping the future of Earth data, geospatial technology, and atmospheric AI across Europe, North America, and beyond. In each episode, we take a vertical dive into a topic chosen by our guest, giving you a front row seat to the ideas, the tools, and the challenges that enable innovation from space to subsurface and everything in between. Today, I'm joined by Stefan, co-founder and CEO of Tilebox, a next-generation space data and Earth observation platform designed to reimagine how we manage, process, and distribute satellite imagery at scale. Before launching Tilebox, Stefan spent several years working at the intersection of software, infrastructure, and space systems, helping organizations modernize how they store, move, and compute on large geospatial datasets. In our conversation today, we're going to have the pleasure of discussing plumbing. We'll dig into the plumbing of Earth observation at scale, the architectural challenges, the business models, and what the future holds for geospatial infrastructure. Stefan, thank you so much for joining us today. How are you?
Doing great. Thank you. Thanks for having me.
No, it's my pleasure. We've had some discussions for a while now, and I feel like this episode is definitely overdue. Really excited to jump into this one. So I guess before we do jump into those questions, very briefly, did you want to give the viewers, the listeners, just a bit of a brief introduction to Tilebox? I know I've introduced you there, but I feel like there's no better person to add some more context to Tilebox than yourself.
Yeah, for sure. Tilebox is a space data native data management and workflow orchestration solution. It's really designed from the ground up for satellite data or remote sensing data in the broadest sense of any kind, with data sovereignty in mind, with algorithmic independence in mind. All those architectural decisions that you require specifically when working with sensitive data, sensitive satellite data, those are taken care of. And then it's basically connecting, building this software infrastructure layer from the sensor in orbit all the way down to insight that you can then present to the end user and to the customers.
Amazing. So let's start from the beginning. I'm keen to learn a bit more about where you see the most waste or duplication of effort in the space data ecosystem, and what's everyone rebuilding that maybe they shouldn't be?
Yeah, so the starting point from like this, why we started out building Tilebox is like mostly it's two things. It's workflow orchestration and it's cataloging. Basically, every satellite operator builds their own pipeline infrastructure from scratch. It's all the same components, the same problems, and slightly different implementations. It's basically over the years I've seen variations of the same system built dozens of times. It's task scheduling and retry logic and monitoring dashboards, and then new requirements come in, and you have multi-environment processing, and then everything like starts from scratch. Everybody has to re-architect those things from scratch. These are not differentiators. These are not differentiating technologies or anything. It's not part of the core business of satellite operators. Nobody wins a contract because they have a better task scheduler. But teams spend still years building these systems anyways, because existing tooling often doesn't fit space operations enough, so it gets adjusted and adapted a lot. Also, it's a fun thing to do for software engineers.
Yeah,
And then cataloging and metadata systems. So everybody always starts building their own internally in the beginning, but there's a lot of convergence happening, and the main reason I think is not invented here syndrome. Founders come from engineering backgrounds. They like building systems. And then early on, it's sometimes faster to just start building something on your own than it is to use existing tooling.
yeah, and let's talk about the pace there very quickly. Is that due to cost? Is that due to you kind of like decision lines? Is that bureaucracy on top of that? Like, tell me a bit more about why it might be faster to kind of go it alone than to go with everyone else, if that makes sense.
It's because managed systems. So you have two ways of like in the classic sense. You had two ways like before Tilebox. You had two ways of doing it. Either you go and build the system on your own, and then you have control over what's happening. And at a small scale, it's always easier to just write that static catalog or create some local processing that you parallelize on that one node or whatever. Like this is fast to develop, and it's good that people move fast. But then so that's one alternative. The other one would be to go with a fully managed system. So there are some providers that are full on platforms where you put in the raw data, you get up your level 2 data, and then you don't even see what's going on in the in between. And those are the two. And then obviously, like there's a tendency to avoid this loss of control and vendor lock-in. So then people just end up building everything themselves. But that is exactly actually the reason why we architected Tilebox the way we did. Is that as a satellite operator or as a software engineer, you still have full control over your data sets, over your workflows. You can execute them wherever you want. You can start on a notebook. You can move to clusters or clouds as you
Interesting.
go. But there's this dichotomy, I think, where people make a decision early on that they want to be in control, which is good.
Okay, so in extension to that, then I'm keen to understand what's a common best practice in the industry that you actually think is maybe wrong or perceived wrong or maybe incorrect there.
Yeah, so I do think like processing everything in this satellite data industry right now, everything is cloud native and
Yeah.
cloud, and that kind of implies that you're supposed to work in the cloud or process everything in the cloud.
Well, they would
And
have been in trouble yesterday, wouldn't they, with
yeah, there
AWS?
we go. Yeah, exactly. Yeah, yeah.
um,
So this tooling that is being built right now is amazing, and cloud native tooling does not like it shouldn't imply that you have to use the cloud. In my opinion, um, if you're with space data, you have this or satellite data, you have this very central issue of data gravity.
yeah,
So downlinking itself, like if you think about it like that, even shifting the processing to the ground and not doing any on-orbit processing, for example, means you have to transfer large amounts of data that you might not want to transfer. So you have data gravity there already, but then once it's in the cloud and once you process everything and you have your archive in the cloud, you have all these egress fees that are part of the moat of the cloud providers, um, and that can add vendor lock-in. It can add extra latency.
right.
So sometimes processing at the edge, like in orbit, can be cheaper than actually shipping everything to US East 1 and then processing it there.
Okay, fine, understood. Do you feel like we're far too reliant on cloud? And I'm not necessarily just talking in reference to Tilebox there, but do you feel like as a society, do you feel like we are far too reliant on cloud environments?
I think the cloud providers have done an amazing job at advertising their services.
Yeah.
Um, they do provide lots of value added services on top of pure compute and storage. So I don't want to disregard that. We're hosting catalogs and all our hosted services are on the cloud as well.
Sure.
But for satellite data, all the Copernicus data is not on AWS or GCP. So do you copy all that
Hmm.
over? Or other missions, have had great success in using local compute to bring down the cost and actually provide maybe a better algorithm, like have the ability to apply better algorithms that are more compute intensive
Mm.
to their data because they compute it in different environments. But Honestly, like I don't have a strong opinion. I don't think, like, as long as you use spot instances or some sort of cost efficient instances, either on either of the clouds or in your own, have your own, bring your own infrastructure, you should be able to mix and match. And I'm a big fan of just working with what you have, and Tilebox workflows can be executed anywhere. You can write them even across environments if you have some parts
Yeah,
that you want to deploy on premise, another part of your workflow in the cloud. You can do that really intuitively, and that's the whole idea, I think,
mm,
to not like move the data around too much and just bring the algorithms close to the data. That's a lot cheaper than moving the data itself.
sure, sure. And in regards to your research here, we discussed this prior to actually recording this about like vendor lock-in, disguised
Yeah,
as best practice. I feel like we might have just touched on it ever so slightly a moment ago, in my
right.
question to you about becoming far too reliant on cloud environments. But tell me a bit more about this kind of second problem there. You're talking about vendor lock-in disguised as best practice. Why do you deem that as a potential issue?
Yeah, I mean, writing a data pipeline. Basically, there's a big difference in how you would write that for large scale processing and batch processing, and how software engineers tend to think about data pipelines or architecting them when it's about near real time processing. And typically for near real time processing, that it would be very specific services like Lambda, AWS Lambdas, or step functions, or some proprietary services that you can glue together, and like queues that they have available for like data coming in, and you put it in a
Yeah,
queue and then you process that queue and so on. And kind of once you build a pipeline like that, it's very static. It's really hard to iterate. You can't replicate it locally. So it's hard for a scientist to adjust the code and test it out and run, improve the pipeline. And so you're kind of stuck. And uh, uh, when you have requirements from government customers that would require maybe air gap deployments, or deployment on sovereign clouds, then that can be a real issue, because you're locked in, and then you have to duplicate your whole pipeline.
yeah, sure. And tell us about how you potentially see some of these problems play out with defense contractors. I know that was another area that we had touched on very, very briefly, because you also spoke about how uh, cloud practices often optimize for the wrong constraint, and how cloud computing optimizes for like elastic scale and operational simplicity. Tell us a bit more about that next problem there that we've just mentioned, and how there are better practices out there, how you sometimes see this play out for such significant organizations and operations such as mentioned defense contractors.
We're having this, we're having these challenges ourselves, obviously, as well. But the main um, the main difference between a commercial operation and then having classified programs, or having government customers, is that typically the types of environments that they require algorithms to be deployed in are very different. So I know the US has AWS and AWS GovCloud, and you have
Yeah,
GCP, FedRAMP certified services, so on. So there's some overlap, but oftentimes, if you like, as soon as you move out of the US, it's a different scenario. Like you have air gap systems, you have different cloud environments that don't have all these added value services that you're familiar with, and then it can be useful to have the higher level algorithms designed for portability from the start, such that you can, if you anticipate that you're going to have these types of customers, then it's useful to already write your pipeline in a way that can be scalable and can be
yeah,
deployed
yeah.
reliably also in this kind of difficult infrastructure.
So ultimately, you're talking about versatility. you're talking about range there, in how you design your process. Okay, well, that's great. That's great. At this moment in time, there seems to be a lot of hype around on-orbit processing right now. What's real versus what's marketing? And where do you
Yeah,
think we actually are in terms of that maturity there?
that's a really good question. And there is a lot of hype around data centers in space right now. Multiple companies working on that, and I think in the very long term, like thinking about thermodynamic effects of like if you use like orders of magnitudes more energy in data centers than we do nowadays, you're actually heating the globe versus not just indirectly through the change of the gas mixture of the atmosphere, but actually directly by the energy impact. So at that point, data centers in space are a necessity for humanity if we scale that far.
Mm.
At this point, I think there's so this is still quite a ways out, in my opinion, but the economics are real. So there's some constraints that we do have that are absolutely necessitate on orbit processing. So bandwidth between space and Earth is super expensive at this point. It's like a large, like double-digit percentage of the operations cost of satellite missions is just downlink, and it adds latency, it adds cost, and it eats up the margin. So for certain applications, like for maritime monitoring, wildfire detection, or some sort of like change detection, where you like monitoring use cases in general, you really can't make the business work if you're downlinking all the raw data. You have to filter it in orbit and compress. Compression is already helps, but it doesn't make it work in these use cases. So for monitoring use cases, processing is necessary. For other use cases where you're still downlinking the data, you still might want to get rid of useless data, like you want to filter clouds if possible. You want to compress the data in orbit. You want to um, detect if a certain image contains what you expect it to contain, and then only downlink it if that's the case.
And tell us about some of the other businesses in this particular space, and pardon the pun there. Um, I remember us talking a bit about where hardware does exist, companies like Ubotica and Unibap, and how they have like radiation hardened compute platforms that can run meaningful algorithms in space. I've never actually heard of these businesses before. Um, so do I'm not looking to take the spotlight away from Tilebox, but I am quite interested by this idea, because yeah, I've never heard about this before. I'm sure there's a few people that maybe haven't heard about this before as well who are listening.
Right. Yeah. The kind of the trope is that compute for satellites is from the 60s or 70s, or like really old radiation hardened processors that don't have much compute power. But what we're seeing is that there's quite a plethora or a variety of companies that are providing radiation hardened software or slightly radiation modified compute platforms that are available on Earth, like NVIDIA Jetsons and NVIDIA Orins, and companies. Those are companies like Colossus Compute or Unibap that do have all this hardware available off the shelf, commercially off the shelf right now, that is capable enough that you can run meaningful algorithms in space. They have accelerators. Usually there's like a GPU or even FPGAs on those systems, and you have general purpose compute um, available as well, and tons of storage. So this is not hypothetical anymore. These are flight proven systems that are operational today, and actually yeah, you're not even taking the spotlight away from Tilebox, because those are our integration partners, where literally they provide the hardware, they provide the operating system, we do the software infrastructure, at that point, when you have like multi-core systems and like parallelized data pipelines in orbit, you still want a system you need that workflow orchestrator, you need that data management if you want to do change detection, and that's what we build on top. And then comes the application layer for the satellite operator. So the same system that's available on the ground, you kind of need to replicate that in orbit.
It's amazing. That is really interesting, and yeah, absolutely. Shout out to those businesses there. But look, as you well know, this podcast is very much a nod to geospatial data and to Earth observation, and I'm going to dive a little bit into that part there because I do feel like there is this difference in space infrastructure and hardware and space systems. And then those teams that also then play around with the data or make solutions with the data that actually comes from those satellites. I feel like there are, two teams here. So yeah, and a lot of people when they ask me, oh, what do you hire for? Do you hire for people in space? And I actually say not really. A lot of the people I work with are those data engineers, data scientists, software engineers, people in product and technical who either do risk or climate modeling, or those engineers who are building pipelines for satellite imagery, like ingestion. Don't get me wrong, a lot of these people do contribute towards the wider space ecosystem there, but me and the people who are actually building stuff that goes up in space, that there just isn't that synergy there between us both. So I'm keen to understand in the geospatial space data ecosystem, there are many platforms and tools like raster platforms, analytics stacks, commercial imagery vendors. How does Tilebox position itself relative to all of those different types of vendors and businesses there?
Yeah, we think of ourselves as the orchestration layer, not a replacement for those platforms. So
Okay.
in many cases are these platforms are very specific. Like, I don't know, Planet provides imagery and some analytics. Maxar provides high resolution data. Then there are marketplaces and various other companies offering analytics tools or processing algorithms or um, things like that. We don't compete with that. We orchestrate workflows that use those services, and in some cases, we make it easier to access those companies or those organizations' data. And like we have open data integrations with all the major open data programs. And and on the other hand, we make it easy for you to organize the data catalogs of your own internal data. Those are that's kind of how we position ourselves. So you might use multiple of those platforms or providers. You might pull data from stack catalogs, run your own algorithms, and then fuse those results with vector data sets that you fetch from another provider, and then aggregate that and provide an end product to a customer, either on a cadence or on demand or based on certain trigger conditions. And those kind of pipelines and the data management that's involved in that, this is what we do. It's kind of the glue layer to make all these systems work together.
Yeah, do you know what? I think I might have used this analogy before, but I like to use and you've already used the word, like a orchestra in
Yeah,
terms of music references there, for anyone listening. And I like to see in that case Tilebox as the composer, right? And then you've got Planet, Maxa, or Vantor now, or Lanteris,
yeah,
up 42. You've got all these different businesses in different fields, all doing different things, I guess, somewhat contributing towards the same goal, playing that sweet, beautiful music. Would that be correct?
absolutely. Yep.
Amazing, amazing. Well, um, I'm whilst we're talking about this, it's given me like the idea of like airflow and like prefect and Dagster. Are you likening yourself to that format? To that type of tooling or technology there, just so that I can, make sure I get this right?
Yeah. So we didn't take this lightly. We didn't decide this on a whim that we're gonna write our own workflow orchestration solution. Like there's already tons out there.
Mm,
The issue is, so I've been working in the past and building platforms for data processing platforms for satellite operators and downstream as well, like in the geospatial data processing platforms. And we have used these kind of systems, and those are general purpose orchestrators. Um, they work fine in the beginning, and then there's always some odd requirements that come in for satellite data specific pipelines where things are starting to become a bit more brittle or difficult to manage. That could be like as soon as you want to add a data source that is not in the same cluster, or if you want to take part of your workflow and move it onto the satellite, or you want to start, and that part is getting better. You want to use spot instances because your algorithms are so compute intensive that it would be prohibitively expensive to use, you know, dedicated infrastructure. And
yeah,
then, so you need this to be able to run on unreliable infrastructure and so on. So
right.
at that point, it always starts getting tricky. And that is one of the reasons why, those are some of the reasons of why we created the Tilebox.
Sure. So the way in which you're positioning yourself, if I've got this correctly, is you're building space data workflows. Well, if you are building space data workflows, use Tilebox for the orchestration. Bring whatever data sources, processing tools, and delivery mechanisms make sense for your mission, and we'll make them work together efficiently. It's like inviting, a few friends over to your house to make one big bowl of pasta. They can go and sit down and relax whilst you're in the kitchen cooking everything up.
Yep. Yeah,
Nice,
exactly.
amazing, amazing. I big fan of tagliatelle myself, so yeah, that'd be my request. Okay, no, that's fantastic. Walk us through a few like will real world use cases or like pilot deployments where Tilebox has actually made a measurable difference. I'm sure people would be keen to understand what's actually, what Tilebox has done, in action.
Yeah. So and those are always the best. Like those are always the best, like real world examples. We have some blog posts up, but I'll talk about some specific ones actually
Sure.
that might not be online. So one where we've been working with an atmospheric monitoring company, and they had algorithms for in order to process their hyperspectral data for different types of campaigns, there could be drone or aircraft campaigns, or and early in-orbit processing demos, and they showed us kind of scientific in a way. It's already well structured, but still kind of serial. And then so each of those flight campaigns then takes a long time to process, and it was like limited to a single node, and it was in the end for us it was very, we don't tend to, like, it's not our core business model, but in some cases we do help our customers to do this transition or do the initial implementation of the pipeline. In this case it happened, we managed to do that very quickly, and then have the same algorithms on the same data, but now they can process this in a distributed manner across clusters. They can still run locally for development, but then they can, on larger campaigns, they can run this in the cloud and manage to speed this up significantly. And that has a measurable impact on the speed at which they can find the right parameters for that specific use case,
Yeah.
and then provide value to their customers.
Sure. Sure. And as we sort of come towards the business end of this discussion, there, I'm keen to understand what were the biggest gaps you saw in how satellite or Earth data is being handled that inspired you to actually start Tilebox?
Yeah. That's a good question.
Feel free to get as sentimental as possible, by the way. I'm sure people want to really understand the true story behind, why the purpose, the sign, the signal where you thought, you know what, this no longer needs to be an idea, this needs to be a reality?
So basically, with satellites, and it's similar on the ground with data processing on the ground, but with satellites, we started with the what we call the midstream. So it's like between upstream and downstream. It kind of expanded from there a little bit because you can't constrain these problems like that. Like you have the same problems in the downstream, like and going for honor processing as well. But the start was in the midstream. And the reason was that nowadays you can outsource almost everything. Like you can assemble your mission kind of. You obviously, like the launch is outsourced, to some of the launch providers. You can have the satellite bus. Like satellite buses are commercially available right now. You can procure payloads. You can have your custom payloads built and integrated. You can even have satellite operations outsourced and just get access to your mission via an API. All of that is kind of abstracted away already. But then you end up with like 100,000 files in AWS S3 bucket, and then you're on your own. So
Right.
Managing all that raw data, having it quickly accessible in a reliable way, and then having a way to create workflows on that. That was the core. That was actually customer request that drove this. For 2 research missions is where we were like, okay, we've done this, we've built this kind of platforms. Let's build them properly with all our learnings, and then offer it as a service such that everyone doesn't have to learn the same things over and over again. And that was the starting point of Tilebox.
It's amazing. It really is interesting. Is there any exciting developments ahead? Is there anything that you can potentially tease on today's episode?
Let me think for a second. I didn't prepare for that.
I was going to say I don't want to get you in trouble.
No.
What we can do is we can ask them to follow the page and to keep up to date with the developments and the ongoings and the outgoings of Tilebox. That is one
Yeah.
thing for sure. And if you want to learn more about Tilebox, then Stefan is your guy. But look, hey, I'd like to thank you for joining me today. It's much appreciated. Really appreciate you sparing the time there. I know that it's been a rough couple of weeks on the health front, not feeling too great, but you are out the other end now and in great spirits, which has been fantastic. As said, this episode is overdue for sure, and I'm hoping that anyone who got to the end here, who's been listening or watching Spotify, YouTube, RSS feed, I'd like to thank you for sparing the time to do so. We really appreciate it, and all I can do is thank Stefan for coming on board. It's been a really really interesting conversation indeed.
But thank you, Sam, for hosting this podcast, and it was a great conversation.
Absolutely. That was Stefan, co-founder and CEO of Tilebox. To those who have been listening and watching to this point, thank you very much for your time. And until next time, all the best and take care. Hello, and thank you for watching today's episode of Earth Observed, powered by DeepRec.ai. If you're interested in joining me for an episode of your own to discuss a topic of your choice, do get in contact with me. And of course, if you are looking to scale your team within geospatial, Earth data, or atmospheric AI, please do get in contact. I'd love to understand how I can support you. Until next time, have a great day.